Welcome to Databases Internal's Interview Crashcasts, your go-to podcast for mastering technical interviews. I'm your host Sheila, and today we're diving into a crucial topic for senior backend engineers: database management systems. Joining us is Victor, a seasoned database expert. Victor, are you ready to tackle our interview question?
Absolutely, Sheila. I'm excited to share my knowledge with our listeners.
Great. Here's our question for today. What is a database management system, DBMS? Describe its main components, including the concept of a schema and how it differs from a database instance. Victor, let's start with the basics. What exactly is a DBMS?
Well, Sheila, a database management system, or DBMS, is essentially software that manages databases. It acts as an interface between the database and its end users or applications, allowing users to create, read, update, and delete data in the database. It's designed to handle large amounts of data efficiently and securely.
That's a great starting point, Victor. Can you elaborate on the main components of a DBMS?
Certainly, a DBMS typically consists of several key components. First, there's the data itself, which is stored in the database. Then we have the database engine, which is responsible for accessing, locking, ingesting, and modifying the data. There's also a query processor that interprets database queries and directs them to the database engine. Additionally, we have a data dictionary or catalog that stores metadata about the database structure, and a transaction manager that ensures data integrity during transactions.
That's quite comprehensive. Now let's focus on the concept of a schema. Can you explain what a schema is in the context of a DBMS?
Of course, a schema is essentially a blueprint or structure of the database. It defines how data is organized and how the relations among them are associated. It's a formal description of the database structure, including tables, fields, relationships, and constraints. Think of it as the logical design of the database.
Interesting. So how does a schema differ from a database instance?
Great question. While a schema is the structure or design of the database, a database instance is the actual content of the database at a particular moment in time. In other words, the schema is like the blueprint of a house, while the instance is the actual house with all its contents at a specific point. The schema remains relatively stable, but the instance changes constantly as data is added, updated, or deleted.
That's a helpful analogy, Victor. Now, let's dig a bit deeper. How might a database architect approach designing a schema for a large-scale application?
When designing a schema for a large-scale application, an architect needs to consider several factors. They'd start by identifying the entities and their relationships. Then, they'd normalize the data to reduce redundancy and improve data integrity. They'd also consider performance implications, such as indexing strategies and partitioning for large tables. Additionally, they'd think about scalability, ensuring the schema can accommodate future growth. It's also crucial to consider data access patterns to optimize for common queries.
Excellent points. Now, let's consider an edge case. How might a schema need to be adjusted to handle unstructured or semi-structured data?
That's a great question, Sheila. Traditional relational databases with rigid schemas can struggle with unstructured or semi-structured data. In such cases, we might consider using a NoSQL database, which stands for Not Only SQL, and is designed to handle various data models, or implementing a hybrid approach. For instance, we could use a JSON or blob column type within a relational database to store semi-structured data. Alternatively, we might use a document-based NoSQL database like MongoDB, which allows for more flexible schemas. The key is to balance the need for flexibility with the benefits of structure and consistency that schemas provide.
Thank you, Victor. That's a comprehensive look at database management systems, schemas, and instances. Before we wrap up, do you have any final tips for our listeners preparing for interviews on this topic?
Absolutely. I'd advise listeners to not only understand the theoretical concepts, but also their practical applications. Be prepared to discuss real-world scenarios where you've designed or optimized database schemas. Also, stay updated on modern database technologies and trends, such as distributed databases and new SQL systems. Lastly, practice explaining these concepts in simple terms, as that's a valuable skill in both interviews and on the job.
Excellent advice, Victor. To our listeners, remember that understanding DBMSs, schemas, and instances is crucial for any senior backend role. Common pitfalls include confusing schemas with instances, overlooking the importance of proper schema design, and not considering scalability in schema planning. Practice articulating these concepts clearly and be ready to discuss their practical applications. Thank you for tuning in to Databases Internals Interview Crashcasts. Until next time, keep learning and happy interviewing.